Okay, today we're going to be looking at the addition rule of probability, chapter 10, chapter 6. So, probability is the measure of the chance that a given event will occur, expressed as a ratio between 0 and 1. You can think of it as a percentage as well, the percentage between 0 and 1, but E is the event, so probability of E being equal to 0 means that the event will not occur. The probability of it happening is 0. Probability of the event being equal to 1/2 means that it is equally likely to occur and not occur. Okay, so 50% chance it will occur, 50% chance will not occur. And then if the probability of E is equal to 1, then E is certain to occur. Now, the probability can lie anywhere in between any of these points. For a simple event, an event that has a single outcome, like rolling a die, that would be considered a simple event. Compound event would be two or more simple events. Mutually exclusive events, events that cannot occur at the same time. Okay, they have no common outcomes. So for example, drawing a single card from a deck of cards and having it be both a queen and a king is mutually exclusive, okay? It can be a king and also a club. It can be a king and also a diamond, but it can't be a king and also a queen. Mutually exclusive. Those events, the event probability of, or the event drawing a king is mutually exclusive from the event drawing a queen. The addition rule probability says that the probability of A or B occurring, remember that or, this is really a probability of A union B, okay, or A or B, is equal to the probability of A plus the probability of B minus the probability of A and B. Okay, so that would be the intersection. And that should make sense because when you look at a Venn diagram, if you add the probability of A to the probability of B, then you have to subtract the overlap or you'll count for it twice. And that would be the overlap, which would be the intersection right here. So what is the probability that you randomly select a card from a deck of 52 cards and it is a king or a queen? Okay, so we'll call this probability of king or queen. Okay, so the probability of that would be the probability of a king plus the probability of a queen minus the intersection of king and queen. Okay, so the probability of a king, that would be 1 over 52. Nope, sorry. There's actually 4 of those, 4 over 52. It's 4 kings. Probability of a queen, that's also 4 over 52. And then the probability of a king and a queen, well, those are mutually exclusive. There's no such probability. That's not going to happen. So, probability is 8 over 52. Or, if we simplify that, let's see what that is. That's 2 over 13. So the probability is 2 over 13, which is about 0.1538. Okay, and you can think of this as a percentage. Okay, you can think of this as there's a 15.38% chance of this happening. Okay, but we don't write the probability as a percentage, we write it as a decimal, but you can think of it as a percentage. That will make it easier to understand what that probability is. I guess we rounded it, but same difference. Okay, Keisha has a stack of 8 baseball cards, 5 basketball cards, and 6 hockey cards. If she selects a card at random from the stack, what is the probability that it is a baseball or a hockey card? The probability that it's a baseball or hockey. Okay, well, how many cards do we have in total? We have 19 cards in total. Okay, so the probability that is a baseball card, that would be 8 out of 19. Whoops, sorry. This would be using the addition rule. It's the probability of a baseball card plus the probability of a hockey card minus the probability of a baseball card and a hockey card, which in this case, those are mutually exclusive. You can't draw both of those at the same time. So we have 8 over 19 plus 6 over 19 minus 0. That's not going to happen. So you have 8 plus 6, which is 14 over 19. And we turn this into a decimal. So 0.737 if we round it. Okay, so this is the answer. You can think of this as there being a 73.7% chance of drawing a baseball or hockey card. Now, sometimes you have events that are not mutually exclusive. This is also known as inclusive events, which would be drawing a single card from a deck of cards and having it be both a king and a spade. Okay, because kings and spades are not mutually exclusive. Okay, they overlap. Okay, kings, for example, the king of spades falls into the king category and the spades category. So events that are not mutually exclusive also use the addition rule, of course. So what is the probability of drawing a king or a spade from a standard deck of cards? So we want probability of king or a spade. Okay, so that's probability of a king plus the probability of a spade minus the probability of a king and a spade. For the probability of a king, there's of course 4 out of 52. Probability of a spade, okay, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There's 13 out of 52 minus the probability of a king and a spade. There's only one instance where a king and spade occur, so 1 out of 52. So that's 17, 16 out of 52, which simplifies to 4 over 13. So this is the probability. We can turn it to a decimal to make it easier to understand. So 0.308, we round it, or about a 30.8% chance that you either draw a king or a spade. What is the probability of drawing a heart or even number from a deck of cards? So probability of a heart, whoops, and or even number. So this probability of a heart plus the probability of an even number minus the probability of the intersection of heart and even number. So the probability of a heart, well, there's 13 out of 52. Probability of an even number, okay, well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There's 20 out of 52. And then we have to subtract the intersection, ones that are hearts and evens. Okay, so heart and even, there's 1, 2, 3, 4, 5. So minus 5 out of 52. 30, so 20, 33, so 28 out of 52. So that can be simplified by 4. And 4 goes into 28 7 times. So 7 out of 13. You can write as a decimal, so 0.538, which is about a 53.8% chance that you would draw a heart or an even number.